So today we're going to talk mostly about how to find the derivative of sine x and what we can use that with and for. So the first thing to note is we're going to need a handful of formulas. Generally a good place to go if you're looking for formulas, mathworld.wolfram.com is a reliable place to find formulas or information, mathematical information that you may need. In particular today, we need the top formula, the sine of the sum of two angles. For homework, you will need the cosine of the sum of two angles. Excuse me. Some other things that we'll need throughout the day, some other trigonometric identities. Sine squared theta plus cosine squared theta equals 1. So if we have an angle, which typically when we're talking about angles, we call them theta. If we take the sine of theta and square it, take the cosine of theta, square it, add those two values together, we'll always get 1. So when we write cosine squared theta, what we're saying is take the cosine of theta, find that value, find your theta, find if it's an angle of a right triangle, find the length of the adjacent side divided by the length of the hypotenuse, and then square that value. So when we say cosine squared theta, we mean cosine theta, that value squared. So since we know sine theta plus cosine squared theta equals 1, we can actually get two more identities from this one. If we divide each term by cosine squared theta, sine squared over cosine squared is sine theta over cosine theta, that value squared. Sine theta over cosine theta is tangent. So this is tan squared theta. Cosine squared theta times divided by cosine squared theta is just 1. And 1 over cosine squared theta is secant squared theta. So we should probably review secant, cosecant, and cotangent real quick. So when we have our standard trigonometric functions, sine theta, cosine theta, tangent theta. If we find their reciprocals, 1 over sine theta, 1 over cosine theta, 1 over tangent theta, we have trigonometric functions for these values too. 1 over sine theta is cosecant theta. 1 over cosine theta is secant theta. And 1 over tangent theta is cotangent of theta. So something to remember, something to note, is the cosecant does not go with the cosine. So cosecant goes with sine, secant goes with cosine. So in each pair, there's one co. So we have tangent and cotangent, sine and cosecant, cosine and secant. So each definition, each pair has one co. So we can also get this other identity by dividing sine squared theta plus cosine squared theta, dividing each term by sine squared theta. Sine squared theta divided by sine squared theta is 1. Cosine squared theta divided by sine squared theta is going to be cotangent. 1 over sine squared theta will be cosecant squared theta. So this is how we can get each of these identities from sine squared theta plus cosine squared theta equals 1. So now we're going to use some of those one of those identities or two, and that definition. Not on this page though. Okay, so, oh, no, I know what I'm doing. To find the derivative of sine x, we have the definition of the derivative, the limit as h approaches 0. The derivative is not just f of x plus h minus f of x over h. It is the limit as h approaches 0 of this quotient, f of x plus h minus f of x over h. So now we apply our function f of x equals sine x. So f of x plus h is sine x plus h minus sine x over h. So now we're going to apply that sum formula from a couple slides back. So I copied the formula up here. Sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. I will say that if you need any of these trigonometric identities, I will provide them for you. These are not identities that need to be memorized. So plugging in x for alpha, h for beta, I write out our definition of the derivative. So we have the limit as h approaches 0. Sine x plus h becomes sine x cosine h plus sine h cosine x minus sine x divided by h. I'm going to shrink that, put it next to so now all I've done, sorry, I typed this up and forgot the order. All I've done is applied the commutative property and switched sine h cosine x with minus sine x. So now I'm subtracting sine x, and now I have sine h cosine x over here. So now we have over here, I can factor out sine x. I have sine x times cosine h minus sine x, so I can factor the sine x out and get -1, plus sine h cosine x. Since I have a limit of a sum, I can split that up into the sum of the limits. So all I've done is take the limit as h approaches 0 of sine x cosine h minus 1 over h, plus the limit as h approaches 0 of sine h cosine x over h. And then finally, we can rewrite this as sine x does not depend on h. So in terms of the limit, sine x is a constant. It does not depend on h. So we can factor sine h out, or cosine x outside. We can pull the sine x outside of the limit since it does not depend on h. For this limit, similarly, we have cosine x, which does not depend on h, so we can pull the cosine x out in front of the limit. So this is the limit we are going to focus on. So we need to know two limits. We need to know the limit as h approaches 0 of sine h over h, and we need to know the limit as h approaches 0 of cosine h minus 1 over h. The limit as h approaches 0 of sine h over h, there was a video for you to watch and follow along and submit for homework. So for homework, you proved that the limit as h approaches 0 of sine h over h was equal to 1. So now we will take the limit as h approaches 0 of cosine h minus 1 divided by h. So we need to prove this limit. So the first thing we're going to do is multiply by, so we have cosine h minus 1, we're going to multiply by cosine h plus 1. If we multiply our numerator by cosine h plus 1, we multiply our denominator by cosine h plus 1. The numerators gives us a difference of squares. Cosine h minus 1 times cosine h plus 1 will be cosine squared h minus 1. So the numerator becomes cosine squared h minus 1. And then I'm just merging the denominators, h times cosine h plus 1. Cosine squared h minus 1, we saw on a previous screen that sine squared h plus cosine squared h equals 1. If I subtract 1 from both sides, we have cosine squared h minus 1. So cosine squared h minus 1 is equal to negative sine squared h. So when I typed up the notes, I apparently forgot the negative sign. There should be a negative sign in front of sine squared h. So I'll need to make sure that I track that through. We can split sine squared h. Oops. Hold on, let me actually put that negative sign over here. So we have the limit as h approaches 0 of sine h over h times negative sine h over cosine h plus 1. Since we have the limit of a product, we can write that as the product of the limits. Remembering to put my negative sign in there. For homework, we showed that this value goes to 1, and we can plug in h equals 0 into this limit. So let's see what we get. So we saw that the limit as h approaches 0 of sine h over h is 1. The limit as h approaches 0 of minus sine h over cosine h plus 1 is negative sine 0 over cosine 0 plus 1. And this is why I didn't catch my negative sign, because sine of 0 is 0. So negative sine of 0, no, not what I want, is still 0. So we have 1 times 0 over cosine of 0 is 1 plus 1. So we have 0 over 2, which is just 0. So we've shown here that, so for homework, we found that this limit equals 1. The limit as h approaches 0 of sine h over h. We just showed that the limit as h approaches 0 of cosine h minus 1 over h equals 0. So sine x times 0 is 0 plus 1 times cosine x. So the derivative of sine x is cosine x. There. I'll let that sit for a minute. So it becomes really nice when finding derivatives of certain trig functions. It would be really, really nice if the derivative of cosine was sine, but unfortunately that's not how it works. For homework, you're going to follow a similar pattern to what we did here and show that the derivative of cosine x is equal to negative sine x. So that's why you're going to need this formula. And then we can assume, oops, going back to this slide, we know that the limit as h approaches 0 of cosine h minus 1 over h equals 0. The limit as h approaches 0 of sine h over h is 1. Anything that we've already proved, you can use. But right now, we're going to use this derivative to find the tangent of x. Actually, before we do this, I'm going to slip in, I'm going to insert a slide. And we're going to draw a quick sketch of the sine. So, oops, y equals sine x, and then in green, or let's do red, it stands out a little better, y equals cosine x. Ah. So we talked about the derivative tells us our slope. So we can see right here, our slope is the value of the red curve, not the slope of the red curve, just the value of the red curve. So we know that this value is 1. We know sine and cosine reach maximum values of 1 and minimum values of -1. They go up and down between 1 and -1. And our sine curve is increasing. So the value of the derivative should be positive. It is above the x-axis. Then we can see here our slope is 0, which should line up to where the red curve crosses the x-axis. It doesn't quite in my sketch. It's a rough sketch and not quite to scale. But we can see it should line up where the red curve crosses the x-axis. The blue curve is horizontal. So now if we look at the slope of our red curve, we can see that our slope at 0 is 0. It's horizontal right here. But then it decreases. Right after 0, cosine x starts to decrease. So our derivative cannot be sine x, because right after x equals 0, sine x is positive. So it's not going to represent the derivative of cosine. So it's not sine x, but minus sine x. So to find the negative value, we flip the graph upside down in the x-axis. So we can see that the yellow curve and the blue curve are mirror images through the x-axis. So you're going to show that for homework. Just follow the same steps for finding the calculations for sine x. So now we're going to use the derivative of sine x is cosine x. The derivative of cosine x is negative sine x to find the derivative of tangent x. So we will find the derivative of tangent of x by using the definition of tangent. So we're going to find the derivative of sine x over cosine x. We need to use the quotient rule. The quotient rule says, so if we have the derivative of the function f divided by the function g, this is g f prime of f prime minus f g prime. So low d high minus high d low over low squared. So the low value is cosine x, the value in our denominator, times the derivative of our numerator. The derivative of sine x is cosine x, minus the numerator high, just sine x, times the derivative of the denominator, so d low. The derivative of cosine x is minus sine x. And divide all of this by the denominator squared. So we can write that as cosine squared x, not theta. cosine squared x. So let's simplify our numerator and see how much we can simplify. Cosine x times cosine x is cosine squared x minus a negative becomes plus. Sine x times sine x is sine squared x divided by cosine squared x. Sine squared x plus cosine squared x, or cosine squared x plus sine squared x, equals 1. So this equals 1 over cosine squared x, which the definition of 1 over cosine x, so 1 over cosine x is not cosecant. Remember, each pair only has one co. This is just secant x. So using the fact that 1 over cosine x equals secant x, we have 1 over cosine squared x is equal to secant squared x. So the derivative of tangent, tan x, is secant squared x. I want to say any questions, and I can say any questions, but there's no one. You're just watching a video at this point and can't directly ask me the questions. If you have questions, please email me and let me know so that I can answer your questions, so that you can understand how we found, how we used our limits, how we used the definition of a tangent as sine over cosine, and then used the quotient rule. I want to make sure you understand how we're using each different piece to solve these problems. So now we're going to solve a problem from the book. It says, suppose f of pi over 3 equals 4 and f prime of pi over 3 equals negative 2. So all I know about my function f is the value at pi over 3 and the slope at pi over 3. I don't know anything else about my function. Using f, we can define two new functions. We have g of x. G of x is equal to f of x times sine of x. So here we have a product. We have h of x, which is equal to cosine x divided by f of x. So now we want to find the derivative of g, which is f of x times sine x at pi over 3, and the derivative of h, which was our quotient function, at pi over 3. So in order to find these values, we're going to need to know sine x, cosine x at pi over 3. So some good values to know. So here's radians. We will typically work in radians, not in degrees. Though it's helpful to remember pi over 6 corresponds to 30. Pi over 3 corresponds to 60. Pi over 2 is 90, and pi over 4 is 45 degrees. So we can calculate sine of theta at pi over 3 and cosine of theta at pi over 3. So we'll come back to this chart to reference our values. But let's see if we can solve for g prime of pi over 3 and h prime of pi over 3. So in order to find the derivative, excuse me, I'm first just going to copy my function, get it out of the problem and on to my screen, separated from the problem so I can work with it. So g of x is equal to f of x times sine x. So now I want to know, what is g prime of x? So I want to take the derivative of a product. This is not the product of the derivatives. We need to apply the product rule. Hold on one second. Let me, before the page gets too messy. So the product rule. So if I have f times g, and I want to take the derivative of that, it's equal to the first times the derivative of the second plus the second times the derivative of the first, or whatever order you've memorized that in, as long as you're properly following the commutative law. So I want to find g prime. I have my first f of x times the derivative of the second. The derivative of sine x is cosine x, plus the second sine x times the derivative of the first. Oops. The derivative of f of x in this case is just f prime of x. I want to know what g prime is at the value pi over 3. So now I plug in pi over 3 for x. So we have f of pi over 3 cosine of pi over 3 plus sine of pi over 3 times f prime of pi over 3. So the values I can pull straight from this screen and this page. F of pi over 3 is 4. F prime of pi over 3 is -2. Now I need to know cosine of pi over 3 and sine of pi over 3. We can flip back. Cosine is 1/2. Sine is √3 over 2. Sine is √3 over 2. And cosine is 1/2. And then we add these. 4 times 1/2 is 2. √3 over 2 times -2. We can erase this and write minus √3. We can't simplify anymore. So here's our answer. Make sure you see how we use the product rule to find the derivative first. Then we plugged in pi over 3 into our derivative function and simplified. We're going to do something similar, but now for h prime of x, we have a quotient. So the quotient rule. So we have f divided by g, and we take its derivative. We have low d high minus high d low over low squared. So again, copy the function. So let's get it out of the problem where we're working so we can see it clearly, and make sure you copy it carefully. There's no signs in this problem, but it's possible when you're copying to miss a sign and then all of your work is wrong. So when you're copying a problem over, copy it carefully. So h of x is equal to cosine x divided by f of x. So h prime of x, we're going to use our quotient rule. So we have low d high, so f of x times the derivative of cosine is negative sine minus sine x minus high, so our numerator, which is cosine x, times the derivative of the denominator, d low, which is f prime of x, divided by f of x squared, which is just our denominator squared. So now we can plug in pi over 3. So we have negative f of pi over 3 times sine of pi over 3 minus f prime of pi over 3 times cosine of pi over 3 divided by f of pi over 3 squared. So I pulled the negative sign out front, and I just swapped f prime and cosine to just keep the f terms in front. So f of pi over 3, again, is equal to 4. So we have minus 4 times sine of pi over 3, which we can look up again. So sine of pi over 3 is root 3 over 2. Cosine is 1/2. Root 3 over 2 minus f prime of pi over 3 is equal to negative 2. All of this divided by f of pi over 3, which is 4, squared. So now we simplify. So we have minus 4 over 2 is negative 2 root 3 minus a negative becomes plus 2 times 1/2 is 1 over 16. So make sure you see how we used the product rule and the quotient rule to solve these problems. And remember, the only information we have about f of x is the value of f at pi over 3 and the value of f prime at pi over 3. We don't know anything else about our functions, but we can still determine g prime at pi over 3 and h prime at pi over 3. So I'm going to wrap up here. There is a Google form. So I copy this down carefully. Be careful of your uppercase and lowercase. I may see if I can get a link into YouTube to this form. It has 3 really short multiple choice questions based on the video. I want you to fill that out to just for participation credit to so I can verify that you watched and paid some attention to the video. I want you to fill that out. It shouldn't take too long. And I hope you guys have a great weekend. I will see you in class next Wednesday.